So we talked about solving systems. Okay, so this is by graphing. We're going to talk about two other methods that are going to be more like solving equations, which I think you guys are going to like better. But this is going to help give us a good introduction to it. Right? So solving systems by graphing. A system is two or more linear equations, and our solution is going to be an ordered pair. So what we saw from our examples was that we could have two lines that intersect at one point.
When they're done today, I'm gonna put the dogs in like the little hole.
Okay, someone's unmuted. Make sure you mute yourselves, guys. Okay, and then we could have infinitely many solutions when the two lines are stacked on top of each other. Okay. Or we could have no solution when the two lines are parallel with each other. Okay. Okay, so from a system of equations, how can we determine how many solutions a system has without graphing? Okay. So how can we determine how many solutions a system has without graphing? So the easiest one to talk about would be when we have no solution. And why am I not working? Hold on a second. Let me charge up real quick. There we go. Okay. Offsite, can you guys see right? No, you can't see anything. Okay, hold on. The joys of technology. There we go. Okay. All right, there we go. Okay, so no solution was the first one we talked about, or one of the ones we talked about. So when we had no solution, the two lines were what? Parallel. And when two lines are parallel, what do we know about them? They never touch. What did we talk about last class? What was something that we knew about those two lines? They had the same what? And had the same slope. So no solution is when the two equations have the same slope, but different what? Different y-intercepts. Same slope, different y-intercepts. Because if they had the same slope and the same y-intercept, it would be what? All real numbers, infinitely many, because they're the same line. Same slope and same y-intercept. You're okay. Just do the best you can. You can copy it down later. Okay. And then our other options, we had no solution, infinitely many solutions, or what was the third option? What was our third option? We had no solution, infinitely many solutions, or a solution. Okay, so just one. So one solution is going to occur when they have different slopes. Okay. They could have the same y-intercept. If they have the same y-intercept, that's the point of intersection. So that would be their solution. Okay. So we're going to look at this example, and this is similar to one you're going to see in your homework today. Okay, so describe the solution set for the system of equations that includes the equation of the line shown and each equation below. So let's start off with figuring out what do we know about the graph. Okay, so what can you tell me about this graph? The y-intercept is 1. Okay, what else can you tell me? What's the slope?
One over 2.
1 over 2. Good job. Okay, so if we start at that y-intercept, we would go up 1 to the right 2. Okay, so that's our slope. Okay, if you did between the 2 points, that would be up 2 to the right 4, which reduces to 1/2. Okay, so either way. All right. So now that we know that, looking at A, y equals 1/2 x minus 1. What do those two things have in common? What is line A and the line on the graph?
Same slope.
They have the same slope, right? Because the slope of this line is 1/2. And since they have the same slope, what does that mean about our solutions? So the two lines are parallel, which means we have
No solution.
no solutions. Remember, same slope, different y-intercepts means no solution. Okay. So no solution. Okay. All right, what about B? X equals 1. What type of line is that? You may remember?
Vertical line?
A vertical line. Good job. Okay. So if we draw this vertical line, okay, so this is for part B, x equals 1. It crosses how many times? Once. So we have one solution. That's what this example is asking us. But on your homework, it's going to ask you to find that solution. Well, we know the x value of our ordered pair is 1. And let's approximate this. What is this y value? 1.5. Perfect. Sounds good. On your homework, I think it'll go through like a nice point, if I remember correctly. All right, let's look at C. 2x plus y equals 6. Okay, when we're graphing, we want to really be in slope-intercept form. What is slope-intercept form? What was it? Or is it? Y equals mx plus b. So how would we get y by itself? Good. Subtract the 2x to the other side. So y equals negative 2x plus 6. Okay, what's the slope of our new line here? Negative 2. Do our two slopes match? No. So it means how many solutions do we have? 1. And since this one's not really going to fit on our graph, we're just going to call it good with one solution. Okay. All right, and let's look at D. X minus 2y equals negative 2. How do we get y by itself? subtract negative x, or sorry, subtract x. So we have negative 2y equals negative x plus 2. And then to get y by itself, divide by negative 2. All right, so we're left with y equals, what's negative x divided by negative 2? What's the number in front of the x? Let's start there. When there's no number in front of x, it would be a 1. So we have negative 1 divided by negative 2. Positive 1/2 x. Okay. And then what's 2 divided by negative 2? How about negative 1? Okay. What's our slope? Oh, it is. Yep, sorry about that. So yes, it should be a positive 1. Okay, so what's our slope? 1/2. And what's our y-intercept on this one? 1. Okay, how do they compare to the graph? They're the same. And if it's the same line, infinitely many solutions. Okay, infinitely many solutions.